6.1, the Polygon Angle Sum Theorems. A copy of these notes in PowerPoint form can be found on Blackboard if you would like to print them out and take your own notes, or you can just take handwritten notes and follow along. The Polygon Angle Sum Theorem, this is the theorem we learned in class. This is the sum of the measures of the interior angles of an n-gon, or an n-sided polygon, is n minus 2 times 180. Basically, this formula is taking the sides of the polygon, however many sides there are, and subtracting 2, which is going to give you the number of triangles you can construct in the n-sided polygon. After you find the number of triangles in that n-sided polygon, you can multiply that by 180, which would be the sum of the angles of a triangle. For example, let's draw a pentagon of sorts here. And if we think about constructing the triangles in this pentagon, you would want to start with one of the vertices. And you only want to work from one of the vertices. So there would be one triangle, two triangles, and three triangles. Okay, the sum of the measures of the angles in each of the triangles is 180. We started with a 5-sided polygon, but we could only construct 2 less triangles. So 3 triangles times 180. Therefore, the sum of the angles of a pentagon is 180 times 3, which equals 540. This is a list of polygons that you should be familiar with. If you ever have or given the names of these on a quiz or a test, I will not be able to tell you how many sides each of these shapes have. A pentagon has 5 sides, a hexagon 6, heptagon 7, octagon 8, nonagon 9, and decagon 10. You should know most of these. Example 1. Using our formula, we're going to find the sum of the interior angle measures of a heptagon. Again, a heptagon is a polygon with 7 sides. Our formula states, take the number of sides, subtract 2, and multiply that by 180. So, we're going to have 7 minus 2 times 180. Simplify. 5 times 180 is going to be equal to 900. Therefore, the sum of the interior angle measures of a heptagon is 900 degrees. Here are a few definitions you need to know. In an equilateral polygon, all the sides are congruent. We do not know anything about the angle measures, only the sides. In an equiangular polygon, all the angles must be congruent. You do not know anything about the sides. All you know is that all the angle measures are equal to each other. In a regular polygon, this is a polygon that is both equilateral and equiangular, so all the sides and angles must be congruent. Okay, let's look at the corollary to the Polygon Angle Sum Theorem. Using this formula right here, basically we're going to find the measure of a single angle in a regular polygon. And this only works for regular polygons. So, let's look at a silly example. Let's look at a square. We already know what the measures of each of the interior angles are, but for just a second, let's pretend like we don't. If we did construct our triangles, we would have 2, and the sum of the measure of the angles of each triangle is 180. So basically, using our formula of n minus 2 times 180, we have the square, which is a 4-sided polygon, minus 2 times 180. 2 times 180 equals 360. So the sum of the angles of a 4-sided polygon such as the square is going to be equal to 360. Since this is a regular polygon and each of the angles are going to be congruent to each other, we're going to take the 360, divide by the number of angles in this 4-sided polygon, and each angle in the 4-sided polygon is going to be equal to 90 degrees. Okay, let's take a look at an example using biology. The common housefly, Musca domestica, has eyes that consist of approximately 4,000 facets. each facet is a regular hexagon. What is the measure of each interior angle in one hexagonal facet? So basically what we're looking for is we're looking for the measure of one angle and only one angle. To get started, we first need to find the measure of all the angles in this hexagon. So using our formula, we're going to take the number of sides in a hexagon, which is 6, minus 2 times 180. 6 minus 2 gives us 4 times 180, and 4 times 180 is 720. Now that we know the measures of all the angles in the hexagon, we're going to take the 720, divide by the number of angles in the hexagon, which is 6, and 720 divided by 6 is going to give you 120 degrees. So 120 degrees per angle in the regular hexagon. In this example, we're going to be using the angle sum theorem to solve for the missing angle, the measure of angle y. Let's go ahead and label angle y as x. We're going to be using a little bit of algebra to help us solve for the missing angle. Since this is a pentagon, the sum of the angles will sum to 540. So let's add up all the angles, starting with the right angle of 90 degrees, plus 120, plus 150, plus 110, plus our unknown angle, which we're calling x. They should all sum to 540. Now, by combining like terms, we have 470 plus x equals 540. Subtracting 470 from both sides, x is equal to 70 degrees. Now, it's a good idea to make sure your answer seems reasonable. In this picture right here, angle x appears to be an acute angle. We found that x equals 70, which is also acute. So it appears that we did something right in this problem. Keep in mind, though, that pictures are not always drawn to scale, so you cannot always rely on the picture alone. Here's our last theorem for this section. It's the Polygon exterior angle sum theorem. It says that the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. So basically, if we take all of the exterior angles, add them together, they will sum to 360. What is really cool about this theorem is that it works for any polygon, no matter the number of sides or whether it's a regular or irregular polygon. One thing that's pretty interesting is if you draw, say, a 100-sided polygon, what's going to happen is those exterior angles, if you keep increasing the number of sides, the exterior angles are going to become smaller and smaller. So it doesn't matter how many sides your polygon has. The sum of the exterior angles are still going to be equal to 360. Okay, let's use that theorem for this example. What is the measure of angle 1 in the regular octagon at the right? In this example, it's nice to know that this is a regular polygon because each of the exterior angles will actually be congruent to each other. So, since we know all the exterior angles will sum to 360, we have 8 exterior angles in this problem. 360 divided by 8 is going to give us 45. So angle 1 is going to be equal to 45 degrees. Here are some practice problems for you to try. There are 4 total. Go ahead and pause the video here. Complete these problems. You must bring these to class tomorrow so we can go over them together. Here are numbers 3 and 4. I hope you guys enjoyed your first video. See you guys in class tomorrow.